Right, back for another in an OMG, it's additional chemistry, and today we're going to look at making salts. We've done naming salts, we've done a pH scale, and we're going to look at the two ways that you need to know about making salts, okay? So the first way is making a salt with a base, a metal, or a carbonate, okay? And there's kind of like a three-stage process, okay? So, react an acid, and normally with the acid you warm it up a little bit to increase the rate of reaction, because as the particles warm up, they've got more kinetic energy, more likely to collide with the metal or the base or the carbonate. So, first off, warm up your acid, doesn't matter what acid, okay? They will give you the acid in the exam. Warm it up and then add in your metal or your metal oxide or metal carbonate and stir it and add it in until no more reacts, okay? And you should see a buildup of excess down here because all the acid has reacted, so no more metal oxide or carbonate can react. Likely to see a colour change, okay? Next thing you've got to do, so the first thing is to dissolve it until there's an excess and there's no more left. Second then, filter the mixture to get a solution of the salt with excess solid left behind. So you're leaving the excess solid here, which will be a metal carbonate or hydroxide, and you'll just have a solution of your acid mixed with your base. Okay, then heat the solution and start evaporating the water. So you're removing the water, you want to evaporate the water off, so you're just left with a salt. Turn the heat off until all the water evaporate, leaving a solid salt behind. You can also leave it for about 24 hours for it to evaporate on its own. So three-stage process: dissolve, filter, evaporate. Okay, and they might say to you, oh, you've got sulfuric acid. Okay, so that's your acid, and we're adding sodium carbonate, and they might say then name the salt. So the salt would be sodium sulfate. So the salt that you're making would be sodium sulfate. You're going to evaporate the water off, which would also make, and you'd also make carbon dioxide, which would bubble off most likely in this bit here, come out in this bit. So you get bubbles of gas. That's another way you could show reactions taking place. Okay. And then the other way, a little bit more complicated, is to make a salt with an alkali. So an alkali is a soluble base, so it's a liquid base, okay? So a base that's a liquid, because obviously with the previous one, it was a solid mixed with a liquid. This is two liquids mixing together, okay? So what you have to do, okay, is carry out a titration. Often you only know the volume of the one. So in this case, we know the volume of the acid. So the volume of the acid is 25 centimeters cubed. We're going to use a fancy pipette, glass pipette, to pipette it into our conical flask, okay? We're then going to fill up our burette with our alkali. In this case, it's sodium hydroxide. So you've got your acid in your conical flask, and then you're going to add your alkali to a burette. Okay, add a couple of drops of indicator, okay, and it should change colour, and then you are going to add from the burette your alkali until it changes colour, okay, until it changes colour, and when you, with phenolphthalein, when you get a permanent pale colour, you take your final reading. So say you started at 0, ended at 17, so then you'd know that you needed to add 17 centimetres cubed of your alkali to your acid to neutralise each other, and then you'll be able to make a salt. Okay, if you want to pause the screen, you can see what's going on there. There's all the information by here. Okay, swirling, stop and add the acid when the end point is reached. Okay, the appropriate colour change in the indicator. Note the final volume reading. Remember that you normally do a trial run first. You do a trial run to see how close you get to the value, and then you normally do at least 3 other readings, and you calculate a mean. Remember to take out any anomalies. So once you know exactly how much acid, so you know how much acid anyway, it's 25 centimeters cubed, you've worked out how much alkali, say it's 17, then you need to run the experiment a final time using the right volume, so the volumes that you've worked out, without an indicator, that's really important. So you run it a final time without an indicator, and then you can evaporate your solution to make the crystals. So, a couple of questions to answer now. Pause the video, have a go at the questions, and then I will write up the answers in a minute. Okay, so what are the 3 stages of making a salt with a metal carbonate? You've got dissolve, filter, evaporate. How will you know all the solute or base has dissolved? There'll be an excess buildup at the bottom. How do you remove the excess base? You filter it out. How is the water removed? It's evaporated, so you're left with just your crystals. If I added sulfuric acid to copper oxide, what would I make? I'd make copper sulfate plus water. What would I use to add the alkali to the flask? Why? A glass pipette. Okay, it's very accurate, more accurate. You've got a higher degree of resolution. Why must you complete a trial run? To work out a close value. So then the next time you can be more specific of the value you need to get to. How do you know the endpoint is reached? The indicator will change colour. Okay, how would you produce? So you'd repeat the titration. Without an indicator. And then you can evaporate the solution after. So you can still evaporate to form crystals. Okay, got it all right? Move on to the next video. If you didn't, go back and watch it again and answer the questions again.